Hello students, how are you all? Hope you are all doing fine. So I'm back with a new video for you all from class 9th today from chapter Gravitation. Students, till now we have studied about what is motion and what brings about motion in any object. So forces which are responsible for bringing motion of the object. These two topics we have studied in our previous chapters. Now under this chapter we'll study more about a particular kind of force, how it all started and what is the theory behind gravitation. What is gravitation? What is the theory behind gravitation? How did it all start? So it is taken like once upon a time kind of story. Once upon a time, it is said that Newton was sitting under an apple tree. He was sitting under a tree and what he observed there, an apple fell down onto his head. He was sitting under a tree and he observed that the apple fell down onto his head. That made him think another point because he had already studied that motion can happen if and only if there is some force responsible behind. Now secondly, he also has framed out three different laws. If you remember, we have studied about Newton's laws of motion, wherein for first law that was related to the states, that relates to inertia, and it stated in the absence of external force, right? In the absence of external force, inertial state retains. Means if the object is at rest, it remains at rest in the absence of external unbalanced force. And if it was in the state of uniform motion, it will continue to move with the same velocity. Second law stated about the acceleration and its relation in terms of momentum as well. Mathematically, it stated and gave the idea and concept of force, which is equals to m into a, and was also taken as change in momentum per unit time. So that relates to Newton's second law. We studied about third law also, where action and reaction, two forces, they were equal and opposite. Action and reaction, they are equal and opposite forces. So Newton had already framed out all these laws and everything he had studied about. What made him surprised more here was that if this apple is falling down, there must be some force which is making to move it downward. Fine. He said it's okay. The gravity of earth is pulling that apple down. But then, according to his own very third law, if this is the action force, there must be some reaction force. And these two, you remember, we studied the action and reaction force, they always act on two different objects. So here, apple was the first object, earth was the second object. Earth applied a force, F, applied by earth on apple. So I am writing it as F-E-A. Earth applied a force on apple and apple in turn must also apply a force because action and reaction forces are to be equal. So according to Newton, he thought if earth is attracting apple, so apple also would be attracting earth with a force applied by apple on earth. And for him, these two forces must be equal and opposite also. So we had got the relation कि force applied by apple on earth was equal and opposite to force applied by earth on apple. But to his surprise, apple, it fell down, but the earth didn't rise up. Earth didn't rise up. Earth didn't seem to rise. Why? If this force was equal, then why earth didn't rise? So, for this chapter of gravitation, the very first concept-based question that I will be discussing is this only, that if apple falls down towards the earth, why is it that the earth does not seem to rise up towards the apple? So, for this, we will be counting the second law as well, which states force is equal to m into a. Now, first I am calculating this force which was applied by apple on earth. Let's say mass of apple be small m and acceleration which was produced in the apple, because FEA was force applied by earth on apple. So for that, it was the force applied by earth. We'll be taking the mass and acceleration for earth on that side. So here m is the mass of apple. I'm writing it ma into acceleration produced in apple. Fine. Which is equal and opposite to, force applied by earth. Earth ka mass, that's mass of earth, into acceleration produced in earth. That is to be there. Now, these two are in the product part. Here also the two terms are in product, right? Magnitude wise, because minus sign is only showing us the direction upward and downward ke liye. So if I consider only the magnitude, we have this thing with us left. Mass of apple into acceleration produced in apple equals to mass of earth into acceleration produced in earth. On comparing these two, mass of apple is very, very less as compared to mass of earth. Mass of earth is in powers of 10 to power 24, but mass of apple in grams only. So mass of apple is very, very less as compared to mass of earth. In order to have these two products equal, therefore, acceleration in apple and acceleration produced in earth. Now you only need to think over, if the product of these two terms is to be equal to these two. मतलब एक example ले, if I say 4 into 16 is equal to 64 into 1, ठीक है? And first term as compared to this side is greater. So obviously the other two terms which are there, then the other term on this side needs to be greater. Means acceleration of apple will be much greater than the acceleration produced in earth. And this was the reason that apple falls down, but earth does not seem to rise. But earth does not seem to rise. I hope I am clear with this point. Earth does not seem to rise because the acceleration produced in earth is very, very, very less as compared to the acceleration produced in apple. Got the point? Coming to the second point, that we know our whole galaxy is made up of different heavenly bodies. Basically or majorly counting on, there are planets, satellites and stars in it. Other than this, there are meteors, meteorites, comets, etc. Many other heavenly bodies also. But basic ones which you study right from your very junior class, from second, third, basically right from even from your home only, you get to study about sun, earth, moon, right? So they form a part of our galaxy. Planets, satellites and stars, they all are a part of our solar system also. When we count, sometimes, see, when I was a little child, no, it always surprised me. I always kept on thinking, कि why can't moon come onto the earth? हम उसे बोलते हैं चंदा मामा. तो चंदा मामा अर्थ तक आ क्यों नहीं जाते हैं? फिर सुनते हैं नहीं, साइंटिस्ट दे हैव ट्राइड एंड दे हैव रीच्ड मून. वेरी गुड. इफ दे हैव रीच्ड मून, इट मीन्स दैट मून इज स्टेइंग देयर ओनली, दैट दे नो कि हाँ ये तो यहीं रहता है. सो मून इज फिक्स्ड. बट नो, दैट वाज आल्सो नॉट द केस. Moon keeps on revolving around Earth. We were told that if I count on for taking an example of Sun, Earth and Moon, right? Sun, Earth and Moon. Sun का size थोड़ा और बड़ा करते हैं so that no confusions happen. So we have Sun, Earth and Moon. Earth revolves around the Sun. Moon revolves around the Earth. And Earth, it rotates on its own axis also. Rotation and revolution you all know about. Now the question comes, is there some kind of binding force which is making them move in the orbits and keeping them in their place? कभी तो आपने सोचा होगा ना कि पूरा का पूरा यूनिवर्स में इतनी सब चीजें हैं, हाउ आर दे बाउंड अप? किस तरह से आपस में बाइंड हुई हैं कि हमें नहीं पता चलता कि कभी ऐसा हो जाए मून जो है अर्थ में गिर जाए या अर्थ जो है वो सन में हो जाए, मिक्स हो जाए, कोलैप्स हो जाए. नो, एवरीथिंग इज देयर. एंड वी ऑल नो अबाउट वन मोर थिंग कि अर्थ का भी अपना एक ग्रेविटेशनल पुल है. तो वो उस पुल की वजह से नेवर एवर इट हैपेंस कि मून उसके अंदर ही गिर जाए. हम बॉल ऊपर फेंकते हैं, बॉल तो नीचे आ जाती है. तो मून भी तो ऊपर ही है. मून को क्या अर्थ का फोर्स पुल नहीं कर रहा अपनी तरफ? अगर वो उसको अपनी तरफ पुल कर रहा है तो व्हाई डजंट मून फॉल इनटू अर्थ? आंसर टू ऑल दीज क्वेश्चंस is in this term gravitation. See, gravitation है क्या? When Newton studied about gravitation, what he said, अभी हमने पढ़ा ना, उसने ये तो बोल दिया कि एप्पल था that was coming down towards the earth, it fell under the effect of earth's gravitational pull, कि अर्थ ने उसके ऊपर एक फोर्स लगाया था, that was the earth's gravity. But then when he further studied it in depth, then he got to understand this concept कि it does not apply only to the lighter objects or only to the heavier objects like earth, but he got into greater studies, in depth studies, and what he found that in this whole universe, each and every object in this universe, each and every object attracts the other object. Now, each and every object attracts means what? हर कोई अट्रैक्ट कर रहा है. तो मैं भी इस बोर्ड को अट्रैक्ट कर रही हूँ, मैं भी इस पेन को, मार्कर को अट्रैक्ट कर रही हूँ. ये पेन और बोर्ड आपस में भी एक दूसरे को अट्रैक्ट कर रहे होंगे. तो ये क्यों नहीं कोलैप्स हो जाते? Why don't they collapse? What is that force which is keeping them in their place? उनको अपनी जगह पर, उनको अपने पर्टिकुलर पॉइंट पर, अपनी पर्टिकुलर पोजीशंस पर कौन सा फोर्स है जो रख रहा है? सो व्हाट इज दैट फोर्स? दैट ही सेड दैट कैन बी एक्सप्लेन्ड विद द हेल्प ऑफ अ लॉ. पहले उसने बताया, न्यूटन ने, व्हाट सर न्यूटन सेड? ही सेड दैट in this universe each and every object attracts the other objects. हर ऑब्जेक्ट में ये फोर्स, अट्रैक्टिव फोर्स एग्जिस्ट करता है. अब बात आई कि अट्रैक्टिव फोर्स जो एग्जिस्ट करता है वो कितना स्ट्रॉन्ग है. सो दिस फोर्स ऑफ ग्रेविटेशन इज फर्स्ट ऑफ ऑल attractive in nature. This force of gravitation is attractive in nature. Second thing, this force of gravitation can be very, very small, and it can also be very, very large. अब आप सोच रहे हो कि ये क्या बता रही है मैम, एक ही चीज तो हो सकती है, या तो ये स्मॉल फोर्स होगा या ये लार्ज फोर्स होगा। ये स्मॉल और लार्ज दोनों कैसे हो सकता है? ये दोनों हो सकता है। सी, अगर आपको याद हो तो व्हेन यू स्टडी अबाउट नॉन कॉन्टैक्ट फोर्सेस, वहां हम मैग्नेटिक फोर्सेस पढ़ते हैं। मैग्नेटिक फोर्सेस, दे कैन बी अट्रैक्टिव और दे कैन बी रिपल्सिव ऑल्सो। सेम वे दिस ग्रेविटेशनल फोर्स कैन बी स्मॉल एज वेल एज लार्ज डिपेंडिंग अपॉन द ऑब्जेक्ट्स दैट वी आर टेकिंग इनटू कंसिडरेशन। मैंने बोला यहाँ इन दिस यूनिवर्स ईच एंड एवरी ऑब्जेक्ट अट्रैक्ट्स द अदर ऑब्जेक्ट, सो दिस इज ड्यू टू ग्रेविटेशन। एंड वो डिपेंड करेगा कि वो जो ऑब्जेक्ट्स हमने सोचे हैं, द ऑब्जेक्ट्स दैट वी हैव कंसीडर्ड, हाउ स्मॉल और हाउ बिग दे आर। बेस्ड ऑन दैट वी हैव दीज टू कंडीशंस और कैरेक्टरिस्टिक्स ऑफ द फोर्स ऑफ ग्रेविटेशन। तो फोर्स ऑफ ग्रेविटेशन आपका स्मॉल भी हो सकता है और लार्ज भी हो सकता है। होप दैट इट्स क्लियर। स्मॉल कैसे? नॉर्मल सा एक एग्जाम्पल ले लेते हैं। एक एप्पल जो ग्राउंड की तरफ आ गया, अर्थ की तरफ आ गया, मगर एक मून जो अर्थ की तरफ नहीं आ रहा। यहां बहुत ज्यादा फोर्स ऑफ ग्रेविटेशन था, बट मून और अर्थ के बीच में बहुत कम फोर्स ऑफ ग्रेविटेशन है। कैसे? राइट क्वेश्चन। नाउ कैसे पता चलेगा कि ये फोर्स कितना है, कम है, ज्यादा है, किस पर डिपेंड करता है? So accordingly a law was framed. So what universal law of gravitation state is that each and every object in this universe attracts the other object with a force which is directly proportional. Now we will be writing down mathematical form also. अभी आपको ये definition दी, statement के साथ how we can write it in the mathematical form. Each and every object in this universe attracts the other object with a force, right, F, directly proportional to the product of their masses. So it is directly proportional to the two objects, masses of the two objects. We have taken masses M1 and M2 for the two objects. So this force is directly proportional to, if I write magnitude wise, this force is directly proportional to product of these two masses and inversely proportional. For inverse variation, how do we write? It is written as 1 upon. So it is inversely proportional to the square of, for square of distance, I have taken the distance d in between. So it is inversely proportional to, inverse में जब भी आएगा आप ये ध्यान रखिए हमेशा कि वो चीज क्या है, डिनोमिनेटर के साथ वेरी कर रही है ना। So वो डिनोमिनेटर में टर्म आ जाएगी। This force is inversely proportional to the square of distance between them. Now you all are very well aware of that force is a vector quantity. So force has got both magnitude and direction. Magnitude wise we have already taken up these values, and direction wise it states that it acts along the line joining the centers, means center के along act करता है ये force. Clear? So combining these, what is written? We write it as F is directly proportional to M1, F is proportional to M2, and F is inversely proportional to square of D. So I'll combine these three and write it as F is proportional to M1, M2, and it was 1 by D square. So it becomes F is directly proportional to M1, M2 by D square. Now this proportionality is to be replaced. When this is replaced, we write a constant here. That constant is capital G. We'll study what is capital G into M1, M2 by D square. So this becomes the mathematical form for universal law of gravitation. When we study about universal law of gravitation, this formula plays a very, very important role, because using this formula we will be defining this constant we have introduced here. This constant is called as gravitational constant. This is gravitational constant. And to the surprise, what was found, when it was calculated using a very, very sensitive balance, what was found? किया कैसे, अब ये भी देखना पड़ेगा कि ये कैसे जी कैलकुलेट किया। जी को कैलकुलेट करने के लिए व्हाट वाज टेकन, m1 और m2 जो दो ऑब्जेक्ट्स थे, दे वर चोजन ऑफ 1 kg मास, यूनिट मास के m1 और m2 हमने ऑब्जेक्ट्स चूज किए। I'm just repeating it once so that it's clear, then we'll further clear this numerical part, basically the formula part. So what does universal of gravitation state? It states that each and every object in this universe attracts the other object with a force which is directly proportional to product of their masses and inversely proportional to square of distance between them. And being force, being a vector quantity, it acts along the line that joins their centers. So this part is clear. Now we'll study how this constant g, that is gravitational constant, was calculated. We know F is equals to g m1 m2 by d square, where m1 and m2 are the masses and d is the distance of separation between the two objects. If we take m1 and m2 as one unit, if these two are taken as one unit and they are kept in such a way separated by 1 meter distance, मतलब मैंने m1 d और m2 तीनों को ही 1 यूनिट ले लिया, तो मुझे क्या मिलेगा, m1 m2 और d अगर 1 1 1 हो जाएं, clear, if m1 m2 and d, the values are taken as 1, then this gets vanished off and we are left with f is equals to g, means उस टाइम पर जो फोर्स ऑफ ग्रेविटेशन होगा वो वैल्यू होगी आपके ग्रेविटेशनल कांस्टेंट की। किस टाइम पर, जब अगर आप दो ऑब्जेक्ट्स यूनिट मास के ले लो और उनको यूनिट डिस्टेंस से सेपरेट करके रख दो, तो बहुत सेंसिटिव बैलेंसेस, बिकॉज सी वो फोर्स कैसा है, मतलब आप खुद से सोच के देखो, आपको मैं बोल दूं दो 1-1 किलो के कोई ऑब्जेक्ट्स ले लो 1-1 kg के और उनको 1 मीटर दूर रख दो, 1 मीटर इज लाइक योर शोल्डर डिस्टेंस, शोल्डर हैंड्स को थोड़ा स्प्रेड आउट करोगे, दैट्स 1 मीटर, मतलब दो ऑब्जेक्ट्स हैं और वो दो ऑब्जेक्ट्स 1 मीटर डिस्टेंस पे रखे हुए हैं। नाउ व्हाट इज द फोर्स ऑफ अट्रैक्शन बिटवीन देम, डू दे गेट टू मूव टुवर्ड्स ईच अदर, क्या दिखता है आपको, वो दोनों ऑब्जेक्ट्स अपने आप तो एक दूसरे की तरफ नहीं जाते, मतलब in that particular case when these masses were very less and this d distance was also like small, in that case this force of attraction also is very less, और वही force of attraction क्या बोला गया, gravitational constant बोला गया, जब हमने m1 m2 और d को 1 यूनिट ले लिया। अब वो masses 1 यूनिट और जो 1 मीटर से सेपरेटेड थे उनका जो फोर्स कैलकुलेट किया, दैट केम आउट टू बी इक्वल टू अ वैल्यू विच वाज वेरी लेस। कैसे मेजर की, यूजिंग अ वेरी सेंसिटिव बैलेंस, पैन बैलेंस तो यूज हो नहीं पाया, बीम बैलेंस, बिकॉज जैसे बीम बैलेंस में हम कैलकुलेट करते हैं ना मासेस, इस तरीके का एक सेंसिटिव बैलेंस यूज किया जो बहुत माइन्यूट रीडिंग्स भी शो कर रहा था। सो हेनरी कैवेंडिश, ही यूज्ड अ वेरी सेंसिटिव बैलेंस एंड ही फाउंड एंड कैलकुलेटेड द वैल्यू ऑफ capital G. What it came out to be? Let's see that. So the value of capital G was calculated, we got to know, as by using m1 and m2 as 1 kg mass and distance as 1 unit. So when this value was calculated, it came out equal to 6.673 into 10 raised to the power minus 23 Newton meter square per kilogram. On calculating this value of F equals to G m1 m2 by d square. For calculating the value of G, when the sensitive balance was used, what was calculated, the value of G was as 6.673 into 10 raised to power minus 11 units. Now, how will we find out the units for capital G? See, capital G is here. Force you know is measured in Newton, so I'll write Newton. D is in meter, so meter square. That goes with this, Newton meter square. This is in kilograms. These two, kilogram into kilogram makes it kilogram square, and it comes in the denominator making it per kilogram square. I'm writing power minus 2. So you need to remember this value that capital G is equals to 6.673 into 10 raised to power minus 11 Newton meter square per kilogram square. Hope it's clear up to this point. I'm quickly taking a recap what we have studied for the day. In this lesson, I have taught you what is gravitation. First concept introduced was why apple falls down towards the earth but the earth doesn't seem to rise up. Second concept we studied that in this universe each and every object attracts the other with a force. There the concept of gravitation came up when it was formulated as a law that this can be seen for all different objects. May it be your lighter objects or may it be your very, very massive objects. So every object in this universe attracts the other with a force which is directly proportional to product of masses and inversely proportional to square of distance of separation between them. And this force acts along the line that joins the centers of the two objects. Using that, when the value of gravitational constant, which was a constant introduced there, when we calculate the value of capital G using a sensitive balance, it comes out equal to 6.673 into 10 raised to power minus 11 Newton meter square per kilogram square. Understood? And taking up for my next class will be the numericals based on this formula of universal law of gravitation. Till then, this concept needs to be stressed very, very clearly. And at the end of this video, I'll be sharing the next link also where you can find out the numericals practiced on the base of F equals to G m1 m2 by d square. Thank you and take care. Bye-bye. Check the description box for the next video link. Must like, share and subscribe to my channel.